Draw another chair conformation for each of these three compounds and state which one is more stable or is favored at equilibrium. So you want to switch the position of the substituents from axial to equatorial or equatorial to axial. So for this first one, keep in mind there's also a hydrogen attached to that carbon, which is in the axial position, and the bromide is currently in equatorial position. So when you draw the other chair conformer, you want to make sure to switch those two groups. So now the bromine is axial and the hydrogen is equatorial. You want the smaller group to be in the axial position because you have 1,3 diaxial interactions between carbons 1, 3, 1, and 3. And there's steric interactions that occur there. The equatorial position puts the larger group away from the ring and you don't have those interactions anymore. I would highly suggest you build a model to prove that to yourself and show yourself that there are those 1,3 diaxial interactions. So the bigger group between hydrogen and bromine is bromine. Therefore, putting it in the equatorial position is favored because otherwise you'll have steric interactions between the bromide here and the hydrogens on for the 1,3 diaxial interactions. So this chlorine in the second compound is currently axial. If we draw the other chair conformer, we'd want to put it in the equatorial position. And it's more favored to have this chloride in the equatorial position because it's larger than hydrogen, so this chair conformer would be favored. In the final case, we currently have the ethyl group equatorial, so that's going to be favored over putting it axial due to the size of it versus the hydrogen